Today, I'm going to demonstrate what is, at the time of recording and to my knowledge, the first example of an athlete data management system integrating generative AI into their platform as a virtual assistant. I identified generative AI as one of the key potential trends in sports science in 2025. And I think this is a really interesting and exciting demonstration of using it. I'm Jo Clubb, founder and sports science consultant at Global Performance Insights, a company that provides sports science support to professional teams, national governing bodies, sports tech companies, and practitioners and athletes all around the world. So ActionApps offers a bespoke athlete management system. Rather than being completely off-the-shelf solution or a completely built in-house system, it provides a very unique offering whereby, based on Microsoft apps, they build your back-end system for your athlete data management system. But if you have knowledge of Power BI, which is of course something I've spoken about on this channel through the courses designed by Sport Horizon, then you can personalize and adjust your front-end dashboards as much as you want, giving you this quite unique ability to personalize the platform to the needs of your specific team. Now, ActionApps are taking their platform to this new level with the introduction of their virtual assistant, AAVA, ActionApps Virtual Assistant. This is an AI-powered chatbot, which is driven by large language models, the same as what underpins ChatGPT, which again, I've spoken about in a number of other videos on this channel, but it is trained specifically on your team's data and providing you with the opportunity to interact with your data using everyday language. Now, it currently doesn't provide decisions or recommendations, which I think is a sensible approach at this stage as we get started with integrating generative AI into our analysis, but it answers specific questions based on your data. And of course, we're going to take a look shortly at that in the demonstration of the system. AAVA is ultimately designed to improve data exploration, to make it more simple, more efficient, and more effective. So it can give you the ability to ask ad hoc questions of your data and get an instant response, which is allowing us to move away from solely looking at either rigid reports or having to take a really long-term deep dive, normally with the help of a data scientist, to uncover the answers to these questions that come up day to day. So it's allowing us the ability to ask questions of our data without necessarily a specialized data coding or data science skill set. And whilst, of course, I think there's still benefit in developing some of those skills, that opens up data exploration to a number of key stakeholders. And one aspect that I think is really beneficial that we'll see in the demonstration is that AAVA does provide the SQL code that it uses to generate its answers. So this is useful from obviously a validation perspective to see that transparency and determine how it came up with its answer from the data, but also for those who are developing their own coding skill sets, it's a way of looking through the code and potentially then using that on your own system or having a better understanding of data science itself. So I'm genuinely excited to share this demonstration with you because, as you'll see, it gives us pretty instant responses. It can provide us with data visualization, as we'll see. And as I mentioned as well, complete transparency around the coding as to how it came to that answer. Importantly, of course, it is backed by Microsoft security. So in terms of GDPR or HIPAA compliance, that is all in place. And of course, being based on our own data set, then it is particularly relevant to the context of our own team and our own setting, but it also has the ability to scale and grow as our own data sets grow. So I'm genuinely excited by not just the efficiency and the time-saving aspect of this feature, but also the accessibility that it should provide in terms of the sports science insights and the answers that we are seeking from our data. I want to thank ActionApps for sponsoring this video and providing us with demo access to AAVA. And so you'll see here then we have the platform, and initially we have some example questions to prompt us, and we can type in our question down here and it turns it into our SQL code. Now, as you'll see with the demo data set that this is based off of, we have an array of GPS data along with some valve performance testing metrics, including data taken from the Nordic hamstring exercise and counter movement jump test. So I want to start with something quite simple, and I'm going to do this in real time so that you can see exactly the realistic speed of the system. So show me the total distance by player for the most recent game. Pretty open-ended in terms of what I want it to return, but we can see how quick that was. As I mentioned already, we can see the SQL code here telling us exactly how it's come to its answer. And it's presenting the information here in both a table as well as then in a chart. We also have the option to download as a CSV, and we can also download the chart. And you'll see straight away that there is some interactivity here, and we can choose to zoom in, double click to zoom back out, and as I mentioned, download that plot as an image, particularly if we want to then email that off to someone. So that was the total distance by player for the most recent game. Let's say now, rather than a bar chart, which is defaulted to here, I want to ask it to return it as a line graph. Now, if you have used other large language models, you'll probably be used to conversing in a single kind of thread with the system. Now, that is possible here with AAVA, but actually with their default approach to this, they have turned off the ability to converse. And so we actually go and ask a new question. This is due to decisions around training efficiency, cost efficiency, and security. So because we are executing the code in this instance only on our own team's data, and so it's kind of staying in our own internal environment. If we wanted the ability to converse, ActionApps in their environment would have to receive the data back. So it would just be a question around cost and potentially security. That is doable if you want it to be a two-way conversation, but their standard is to ask one question at a time. And I think from what I've seen, that doesn't limit the system at all. We're just asking a new question each time. And certainly if it's a matter of cost and keeping everything on our own system, then that's of benefit. So as I said, we're going to ask a new question this time. This time we're asking still total distance by player for the most recent game, but plot it as a line graph from highest to lowest. And now we can see immediately again that it's been able to follow that prompt. And this time it visualizes the data in a line graph, and also, as per my instructions, has sorted it from highest to lowest. So as you may well know from other videos on my channel, I'm a fan of using Z-scores or standardized scores to add context to our analysis. And I want to see if AAVA can do that. So I've asked for each player's maximum speed for their most recent game as a Z-score compared to all their game day maximum speeds. And here, again, we can see the response. Then we can see that for each player, it's pulled out their most recent game day, their maximum velocity, and their Z-score, how that compares to their averages, and plotted that in bar graph. Quite interesting. So, of course, I would be looking to validate this information against my own data set to make sure that I have written the prompts with enough information to instruct it specifically what calculation I want to do. Also, one thing I think worth pointing out here is that AAVA has been trained on different terminology, and so it can handle typos or different metric names. For instance, we've spoken in our question about maximum speed, but as you can see in the code here, max velocity is the actual metric name, but it's been taught to line up those different terms. So now I want to see if I can add another layer of information and context here. So I'm asking for the same question, but this time to color code the bar chart according to their player position. Let's see what it gives us. Okay, so here we have then our Z scores and color coded by position. We can also interestingly here see the maximum velocity actually plotted on the chart. So that may be something we would want to include or not include in our prompt. And as I mentioned, these are also interactive, these charts. So for instance, I can select and deselect some of these positions if I wanted to hone in on some of these selections here. I think an added purpose of our data exploration with this as well is to check on our data quality. So as sports science practitioners, we really are the data stewards of the information going into the system. And it is our responsibility to make sure that the data going into the system is accurate and complete to enable us to get more insightful analysis. Now let's look at some individual athlete analysis. So I'm going to ask about the average high speed distance in games covered by this athlete, Daisy Ward, per season, but limit that to games where she played more than 85 minutes. So we can see the code for this question. We've got our response of her average game day high speed distance, and that is plotted per season there then. Next, of course, the acute chronic workload ratio is a very debated topic, but just out of interest to see the kind of analysis that the system can do, I'm going to ask it for the acute chronic workload ratio for high speed running for one of the players, Alan Foster, in the 2023 season, just out of interest to see if the platform can handle that question. And we can see the response here then with the table and the chart. And again, as we mentioned before, we can zoom in. Maybe we want to ignore that very early phase of data where it's kind of not relevant at all. Interestingly, obviously, that's quite an open-ended question. And I'm interested to know if I wanted to look at different timeframes, not just with the workload ratio, but maybe I want to be able to change those timeframes, whether the system can do that. We can see that it has calculated acute as the 7 and chronic as 28 days, which I would assume to be the default. So now I want to see if it can respond when I ask to change those timeframes. So here I am again asking for the acute chronic workload ratio for high speed running for a player in the database, Alan Foster, for 2023 season. But I'm asking to include the acute chronic timeframe as 5 days and the chronic workload timeframe is 21 days. And we can see here at the top of the code that it is doing that day -4. So our 5 days of our acute and our today and the -20 days together to be 21. Obviously, we could get into coupled and uncoupled here. We just need to remember whatever approach we want to use to this calculation, we need to include in our prompt. But interesting to see that it understands which factor to change when I include that detail in my request. Let's do some more data exploration then, still looking at longitudinal training load monitoring. So I want to look just at my strikers now and see their most recent week's cumulative player load and also report it as a Z score compared to their average. Okay, something interesting here that is a really good example of perhaps user error. So I think in this example, I probably have not been specific enough in my prompt. I asked for their most recent week's cumulative player load and calculate that as a Z score compared to their average. And it has returned Z scores very high, 28, 50, garbage, essentially. So I think I was not specific enough. It's probably comparing them potentially to their average session player load rather than weekly. Whereas here, I'll just look at the prompt first. I've adjusted my prompt to be calculate that as a Z score compared to their average weekly total player load. And I get their recent weekly player load, their average weekly player load, and of course, a much more meaningful Z score. Really nicely displayed here as well. You can see we've got the actual player load, weekly player load represented in the bar chart, which is then color coded as per the Z score. I'd want to go in and double check that that's correct, if nothing else, more so because of validating the way I have asked the question. So thought that was a really good example of needing to be specific with the question you're asking. Then a similar question along the same theme, if I'm looking at my strikers and I want to know actually which week of the season was their highest cumulative load for high speed running. And again, we've got the week identified from the data set, the high speed distance, and it's even plotting it there for me. So another example of really exploring our GPS data. As I mentioned, currently in this demo account, there's not just GPS, there's also some testing data. So now I'm going to ask about some Nordic hamstring information. You can see I've asked for maximum force in the Nordic test over time for Daisy Ward. We can see we get the results here, as well as a chart as we've been seeing with our other examples. But now I want to see as well if I can combine those two different data streams. So I'm going to ask about each player's highest Nordic force and their highest maximum velocity from GPS, and see if it can plot it in a scatter chart. Okay, so here we have the response with our maximum force and maximum velocity for our players plotted in a scatter plot. And again, as we could prompt it to change the size of the axes, what we've got, but also we can make use then of our zoom function, as we've seen with some of our other charts, to zoom in on some of this information and use it as an interactive chart. Okay, and another example I want to ask, looking at the two different data streams, I'm going to ask about high-speed distance in games compared to RSI modified, which of course is from the jump testing information, 2 days prior. Adding a little bit of complexity now into our questions to not just ask for either the highest or a particular date, but see if it can line up this request. Okay, that was a pretty fast response. Let's have a look here then. We've got our high-speed distance from games, and we've got then 2 days prior, the jump RSI result. And we can see that has plotted that. Again, we can zoom in if we want. Okay, I could keep playing around with that all day, but hopefully that demonstration gives you some insight into how AAVA works and kind of some of the questions and ways that we can use that system. Of course, some really important factors that we've already mentioned in terms of making the most of this approach is the data quality, always so key. That determines the quality of our analysis and our outcomes. We need to be specific with prompts. Obviously there, I was asking at times quite broad questions. So if we're looking for something specific in terms of metrics, timeframes, decimal places, or the charts in terms of how you want it visualized, then you need to integrate that into your question. As I said, the default approach with AAVA is a single question at a time, although it would be possible to turn on more of a conversational style. That would be with a discussion with the team at ActionApps. But clearly the benefit of basing it in your own environment, on your own data set, is to get that real contextual relevance of your own data set. And then like any large language model, that should continuously be learning and hopefully improve over time as it learns more based on the queries and the new data that it ingests. So I'm really excited about AAVA. I think that this approach is going to widen our ability to explore our data more efficiently and hopefully effectively. It helps us to move away from just thinking about our rigid day-to-day reports or dashboards and gives us the ability to very quickly answer more ad hoc questions, all of which can be done using everyday language without necessarily the specialized coding skill set. But of course, we do have the ability to see the code, whether we want to validate how it's come up with its answer or learn more about how we can write the code ourselves. So I want to thank ActionApps for sponsoring this video and enabling us to demonstrate the system here. If you have any questions for ActionApps or would like to discuss this further with them, I'll put links below for ways that you can get in contact with them. And if you found this video useful or interesting, then please like and subscribe so you don't miss out on another Sports Science Insights video coming very soon.